Okay, while we were gone here, I did the calculations for BC. B was 5 comma 8, C was 5 comma 2, so its midpoint was 5 plus 5 divided by 2, which of course is 5, and then 8 plus 2 divided by 5, sorry, divided by 2. I was already thinking of the answer, which is also 5. So we have the midpoint of BC is 5 comma 5. Well, unfortunately, because these match, if you tried finding the slope, you would have, let me actually show you finding the slope here. You would have m equals y2 minus y1 over x2 minus x1. Of course, the x's match. So you'd have 8 minus 2 over 5 minus 5. That's 6 over 0. And you can't divide by 0. Why? BC is vertical. Its slope undefined. Okay? And because its slope is undefined and it's a vertical line, we know its equation should say x equals something. Well, look, what does x equal? 5 in both cases. So its equation is x equals 5. Let me graph that thing. So x equals 5. Graph it. So that's the side. This right here is the second side of my triangle. I got this side. There's a point right there. That's A. That's B. And C is down here. So if I had one more, I would have all three. Um, mm, oh no, that's not C. C's way over here. Or A. A's here. B's here. And C's at that point there. Now we don't get to see all three because I didn't graph all three here. But let me now find the perpendicular bisector. What did I say? Um, well, if if it's vertical, its slope is undefined. So its perpendicular bisector has a slope of 0 and it's horizontal through 5, 5. And if it's horizontal, it has an equation that says y equals, well, what does y equal? 5. So I'm going to graph that as well. I'm going to go graph y equals 5. And there's our horizontal line. So if I could draw the third one on here without actually calculating it, from there, from that point to that point, we'd have right through there. Okay, and that's what you're going to do on yours. You know, you're going to have all three and all three perpendicular bisectors. All right, last step is the point of intersection. So the point of intersection between perpendicular bisectors or triangles is called the circumcenter. Find it by using substitution or elimination method to identify the coordinates of the point of intersection for two of your perpendicular bisectors. So rather than demonstrate this with my lines themselves, I'll just demonstrate in general. If I have two lines and one has these coordinates, or one is this equation, and the other one is 3/4 x minus 2, and I want to solve this system of equations to discover where do they intersect, because where they intersect is the circumcenter, which by the way is the center of the circle. So um, in order to do that, I can use substitution or elimination. Elimination is a method where you try to make the coefficients of either the x's or the y's in one equation the opposite of the other, and then you add the equations together so that all the x's cancel out or all the y's. I'm not going to show you that one here. I'm going to show you elimination or substitution. Since the specific point we're looking for, at that point the x's and y's in one line are equal to the x's and y's in the other line, what I'm allowed to do here is set the two equations equal to each other. So, and that graph obviously wasn't accurate. It was just by way of demonstration. Okay, so I'm going to do substitution. So 1/2 x plus 5 has to equal, at this point of intersection, 3/4 x minus 2. Why? Because both of the y's at that point have to be equal. Okay, so this is a ugly equation with fractions in it, but not hard. I say fraction, you say LCD. So we're going to multiply everything through by the LCD of 2 and 4, which is 4, and I'll get 2x plus 20 equals 3x minus 8. And then I will bring the 2x's that way, making just x. Bring the 8 that way, making 28. So for these two lines, they made at the point 28 comma something. Well, if I know it's 28 comma something, I can plug in 28 here and minus 2 to find out the other something. Or I can go y equals 1/2 of 28 plus 5. Either way I do it, I should get the same answer. Half of that is 14 plus 5. It's 19. 4 goes into that 7 times. 3 times 7 is 21 minus 2 is 19. So either way I cut it, using the first equation or the second, my point of intersection is 28 comma 19. What I want you to do is find it using algebra. And then check your answer by plugging it into the remaining equation. Because you actually have a system of 3 equations, you only need to use 2 equations to find the solution, but check it by plugging it into the third equation. Um, if you did it right, it'll work in all 3 equations, and it will match. This point here will match the point of intersection here, or wherever it is on yours. Obviously, I didn't use this line and this line, and my reason for that was quite simple. The pink line is y equals 5. The green line is y equals 7x minus 2. So I would just plug 5 in for y and then solve by adding 2 and I get 1, and you can see that they meet at 1. So that's a lot easier than probably the ones you'll have. So I didn't want to show you an easy example and then have yours be hard. So basically, use substitution, find the point of intersection, verify that it agrees with your intersection for your perpendicular bisectors on your graph paper. All right, I think that's it for